This video is going to go over how to solve quadratic equations by graphing. I'm going to discuss two different ways of graphing onto your graphing calculator. For this video, I'll be using a TI-84. So the first way of solving by graphing is by what's called determining the zeros. So what we want to do is, in order to solve for the zeros, we're going to manipulate the equation so that one side is equal to 0. Next, what we're going to do is input that function into y1 of your calculator, and then we're solving for the zeros of the function. So that's kind of why I'm calling it this one, by determining the zeros, what we're looking for. And remember that zeros, the other words for zeros is x-intercept, or you may hear the word roots. All of these tend to be used interchangeably when we're talking about quadratics. The second way that we're going to talk about solving by graphing is by finding the intersection points. This one is nice if if you don't want to have to manipulate the equation. So all you're going to do is just whatever you see on the left side of the equation, you're going to input into y1. Whatever you see into the right side of the equation, you're going to put into y2. And then you're going to find the intersection points of those two things. So let's look at an example. So here's two of our examples here. So solve the following quadratic equation by graphing. Here's a really good one where we would want to find the zeros. The reason that we'd want to use that first strategy that I talked about is because of this. We already have it being manipulated where one side is equal to 0, and I have the entire function on the left side. So all I need to do is input this side into y1 of my calculator, and then I'm finding the zeros, which is also known as the x-intercepts or the roots. So when I go into y equals, I'm going to put this in. So we have 2x squared minus 5x minus 13. Depending on what your window is, you may want to adjust it. I tend to start with just the standard window of -10 to +10. And then if I need to adjust from there, I do. And I'm going to hit graph. Here's what we have. So what we're looking for is, when I'm looking for finding the zeros, I'm looking for these 2 points. I'm looking for this point here, the x-intercept, and I'm looking for that x-intercept. On the TI-84 calculator, how you do that is you're going to hit the second function key, and then you're going to hit trace. And what we're looking for is number 2. It's going to ask you to left bound and right bound, so I'm going to just take my cursor, and I'm going to take it physically to the left side of the 0. I'm going to hit enter. And I'm going to take it to the right side, hit enter. And then what I have here is my first 0. So there is a 0 at -1.589 and 0. And my second one is going to be at, let's find that one. So again, second trace, number 2 for 0. You want a left bound, so you want to take it to physically to the left of the 0, and then physically to the right, and it'll guess here for you, and you've got 4.0894 and 0. So what this is saying, and what we're solving for here, is that if I input this x value into the equation above, that is when I'm going to get a y value of 0. Similarly, if I input this exact number, then my output will also be 0. And this is what we're solving for. I'm trying to figure out what x value makes this equal to 0. So my solutions, I have 2 of them. And my solutions would be x equals negative, forgot my negative in there, -1.589. And my second one is x equals 4.0894. Awesome. For the next one, solve the following quadratic equation by graphing. Here, what's really nice is using the second strategy. Instead of having to expand this 2x through the brackets and then move everything over to one side, you can do that if you want to, but what you could also do is just take whatever you see on the left side of the equation and place that into y1 of your calculator. Take whatever you see on the right side and input that into y2. You do not have to manipulate this. You don't have to expand anything. There's no algebra involved here. You can just go ahead and type in what you see. So let's try that out. We're going to have 2x multiplied by x minus 5. And in y2, we have 13. So then let's go ahead. I'm just going to expand my window a little bit here, just so I can see that line at 13. There we go, and there's my 2 intersection points. So in this case, what I'm finding is the intersections. And so on the TI calculator, how we're going to do that is you're going to hit second trace, and intersections, I believe, is number 5. There we go. And so you're going to take your cursor somewhere close to one of the intersection points. You'll hit enter 3 times, and it'll find your intersection point. So we have an intersection at negative 1.0707 and 13. And my second intersection will be at 6.0707 and 13. So what you're solving for here is you're still finding the values of x. So you have, when this value of x is input into the equation, we get it equaling 13. So slightly different than what we were doing before. Overall, notice that the y value doesn't really matter so much. It just tells you what the other side of your equation is equal to. Essentially, what we really care about is x, because that's our input. When I input this x value, I get an output of 13. So my solutions are x equals negative 1.0707 and positive 6.0707. And so just to kind of reiterate this, if I was to expand this equation, so I expand the 2x, so I get 2x squared minus 10x, and then I subtract the 13 over, and I get that equal to 0. You could also graph this. You could put this into y1, and you could find the zeros, and what we would find is that the zeros are at the exact same x value locations. The only difference is that the y value would now be equal to 0. But again, like I said before, the y values don't really matter. Thanks for watching. Let me know if you need any help.